Om Sri Sai Ram. In the previous session, we have discussed the definite integrals as limit of sum. We happen to derive a formula, and by using that particular formula, we were able to find the definite integrals of given function. The basic difference between indefinite and definite integrals is that indefinite integrals can be infinite because with every integration we get a constant of integration, and as you keep changing the constant of integration you have got many solutions, whereas the definite integrals have got a definite value, only one value. And how does it happen? Because we know the limits. We integrate within the limits. So we have a definite value. Whereas indefinite integrals, we don't define limits. As a result, we are not able to get a definite answer. So let us see today the second method. Yesterday what we did was one of the methods. Today is the second method which we are going to discuss in definite integrals. Yes, fundamental theorem of calculus. Yesterday also we calculated area in one particular way. What did we do? We divided the whole interval into n number of parts, n number of strips. And we said that n actually tends to infinity, too big a number. So as a result, the width becomes smaller and smaller, and we said h tends to 0. H is the width. And then what did we do? For each strip, we calculated area and added. So that was the method we followed there. Now let us see the second method which we are going to follow. More or less same, but with small difference. Now see it. Fundamental theorem of calculus. How do we find an area function? We know that we have defined a to b fx dx as area of the region bounded by. What were the boundaries? Try to recollect. Down we have x-axis. In the sides we have got ordinates x equal to a and x equal to b. And in the top we have the curve. So this is the curve y equal to fx. These are the boundaries x equal to a and x equal to b. And then above x-axis. So what is that we are doing here different than what we did yesterday? We simply consider one of the in between a and b a value x. So the moment we do that, if we just draw a line, it divides into two parts. Okay, so the region bounded by the curve y equal to fx, the ordinates are x equal to a and x equal to b and x-axis. Now let x be a given point in between a and b. In between the intervals on x-axis, we are taking a point, the x coordinate being x, okay, AB, then A. So what will happen to calculate this first area? We have to integrate from A to x. This particular shaded area which we wrote A means area of x. We have to integrate between a and x. So a to x fx dx represent the area of the shaded region. How do you calculate? Very simple. In other words, the same thing. The area of this shaded region is a function of x. We know that when we differentiate a function, we get another function. When we integrate a function, we get another function. So when we calculate area also the same thing happens. In other words, the area of this shaded region is a function of x. We denote this function of x as a of x, means area with x, okay. We call the function ax as area of function and is given by a of x equal to, means area of that particular shaded region. Which particular shaded region? This particular shaded region. We are calling it a of x. You can call it anything of your choice, okay. So a of x equal to a to x fx dx. And here comes, based upon this definition, we have two basic fundamental definitions of definite integral. What are they? Based upon this definition, two basic fundamental theorems have been given. However, we only state them. We are not proving it. We are not going to go for the proof because that is done in the college level. Right now, if we know the statement, that is good enough. So what is the first statement? First fundamental theorem of integral calculus is nothing but that only. What is it? Let f be a continuous function. You know, whether it is a Rolle's theorem, whether it is Lagrange's mean value theorem, anything you discuss, the function which you take should be a continuous one. Why? Now suppose if it is not a continuous function, when you draw the graph, in between it will get separated and you will not get what you require. So it should be a continuous function between the limits. What are the limits? X equal to a and x equal to b. That we call it closed interval. And let a of x be the area function. A dash x equal to fx. What do you mean by that? We know that if a of x you are getting as area, you are integrating f of x. Now just think, if you differentiate the first one, you should get the integral. So a dash x is equal to f of x. So that when you integrate a dash x, you get a of x. Okay? X belongs to ab. Go to the next one. This is also a very, very simple one. What is it? We state below an important theorem which enables us to evaluate definite integral by making use of antiderivative. What do you mean by antiderivative? Integration is antiderivative. By using integration, you already studied integration, isn't it? We have solved hundreds of problems based upon integration and definite integral. Okay? So with the help of that, you can calculate same area, which we did by a long method and we called it integration as a limit of sum. Okay? So now what we are saying, let f be a continuous function defined in the closed interval ab. That statement remains same in every theorem. Okay? Let f be an antiderivative of x. What does it mean? See, for example, let us say the function is, let us say f of x equal to sin x. F of x is sin x. Okay. What is its derivative? Cos x. F dash x is what? Whereas, what is integral of fx? Integral of sin x dx, if you take, it is minus cos x. This is what he is trying to tell. So what is that he says? It is antiderivative of f. It is nothing but integral of f. What is area? It is the integral of the given function. Okay, so a to b fx dx is equal to capital Fx. This capital Fx is nothing but what you got. For example, when we took sin x, we got minus cos x. So that fx is nothing but this. Now is something which we need to learn. What is that we need to learn? Because we have introduced the limits and we called it definite integral, you need to know what they mean. Yesterday also we have discussed the a is called lower limit, b is called upper limit. So fx is being integrated, something like sin x is being integrated and we got minus cos x. Okay, and then since if you put the limits here, now let us say if you introduce the limits a to b here, so what do? Here we put the limits a to b. Then what happens? To simplify, first substitute the upper limit in place of x minus substitute the lower limit. So if you substitute b here, it is going to be minus cos b, okay, whatever it is, minus of, means upper limit after substituting, minus lower limit, minus of what is the lower limit? A. So minus of minus cos a. Putting together what you get? Minus of minus will become plus, so it is cos a minus cos b. This is the answer. This is how we have to do. See, already we have learned integration. Now it is going to differ only just in the last step and nothing more. And what is that? Where we substitute the limit. So how do you substitute the limits? If for small fx, the answer is capital Fx, in place of x, first you substitute upper limit, that is f of b minus f of a. Now a question may come to your mind, what happened to constant of integration? It vanishes on its own. How does it vanish on its own? Tell me. Now let us say, for example, when we did integration of fx dx, we got f of x. Now let us say, instead of that we write f of x plus c. And then substitute the limits a to b. What happens? First substitute upper limit. So it will become f of b plus c. Then substitute lower limit minus f of x minus c. So what happens? This plus c minus c gets cancelled and you get f of b minus f of a. So what happens? Automatically the constant of integration vanishes. Why? Because when we substitute upper limit, it will be positive. When we substitute lower limit, because of the minus sign in between, it will be negative. Plus c minus c will cancel. So the headache of plus c vanishes off in definite integral. Okay. So let us move further. Yes. There are some important things to be remembered. What are those things? Just let us go through one after the other. The first point, the same second theorem we are putting in words. What is it actually it is giving? It is giving us area. Okay. So in words, the theorem 2 tells us that a to b fx dx is nothing but value of antiderivative. Value of antiderivative means value of integral for fx. We are assuming that the integral is capital Fx. Okay. So value of antiderivative f of f at upper limit b, that is f of b minus value of the same antiderivative at the lower limit a. That's why we are saying capital F b minus capital F a. Okay. Come to the next point. This theorem is very useful. Why it is very useful? We don't need to have the lengthy method which we followed yesterday of integration as limit of sum. It makes our job so easy. And once you know this is the shortcut, why on earth anybody will go for the other method unless and until the examiner wants you to do by that method alone. Okay. So this theorem is very useful because it gives us a method of calculating the definite integral more easily without calculating limit of sum, which we did yesterday. Next point, the crucial operation in evaluating definite integral is that of finding a function whose derivative is equal to integrand. This is same thing for indefinite integral also. What do we do in integration? We try to find out a function whose derivative is given to us so that when we integrate, we get back the function. Sin x is a function. Its derivative is what? Cos x. So if you have to integrate cos x, you have to find out antiderivative, and which is nothing but sin x, because integration and differentiation are reciprocal operations. Now let us say, for example, a polynomial function. X square is a function. What is its integral? Integral is x cube by 3. Now we say that if x cube by 3 is the function, its antiderivative is opposite, that is x square. For x square, if you integrate, you get x cube by 3 and then vice versa. Steps of calculating a to b fx dx. No big steps. You already know it, how to integrate. Simply integrate the function, substitute upper limit minus substitute lower limit. There ends the matter. So find the indefinite integral first. Don't worry about the limits. Just find out indefinite integral, that is without limits. Let this be f of x. There is no need to keep integration constant, because if we consider fx plus c instead of fx, the same explanation which we did. That is, one side it will be plus c, and then when you subtract it will be minus c, both will get cancelled. Okay. Thus, the arbitrary constant disappears in evaluating the value of definite integral. After that, what we need to do? Simply calculate FB minus FA, which is the value of definite integral. So it's very, very simple. Since you have already learnt all types of integration, in definite integral, what we need to do? Only in the last step, we need to substitute the limits and simplify. So nothing new we are learning here. Nothing new is happening here. Yes, these are the problems from the exercise 7.8, which we will do it. And you know, they are very, very simple because you already learnt all types of integration. Okay, so it's more like a revision. Remember, only in the last step, it will be that we will be substituting the limits. And remember also that there is no more need of writing constant of integration after integration, because it anyway going to vanish. Okay, so let us start. So these are the problems which we are going to take up today. Begin with this, very, very simple, quickly we can do, and as many problems possible we will do. So these are the limits, minus 1 to 1. That is, a is minus 1, b is 1. What is the function? X plus 1. So what is the procedure he has explained? He said, forget about the limits. Don't worry about minus 1 and 1. Simply integrate x plus 1. Tell me, what is the integral of x? Integral of x is x square by 2. What is integral of dx? It is x. And what are the limits? Minus 1 to 1. We finished integration. Now, to complete the problem, what we need to do? We first substitute upper limit. Do that. In place of x, write 1. So it is 1 by 2, because 1 square is 1, plus 1. This is the upper limit. Minus lower limit. Now substitute minus 1 in place of x. So minus 1 square is also 1. So it is 1 by 2. Substitute in place of x minus 1. Open this bracket. So what do you get? You get 1 by 2 plus 1 minus 1 by 2 plus 1. So 1 plus 1, it becomes 2. 1 by 2 minus 1 by 2 gets cancelled. The answer is 2. So simple it is. Okay? Yes. This is our question. So how do you do it? You find that there is combination of many functions. Okay? So each of them you have to integrate, and then finally we will go for limits. So do that. This can be written as 1 to 2, 4x cube. 4 can be kept outside and x cube is the function. Minus 5 can be kept outside. X square is the function. 6 can be kept outside. X is the function. And 9 can be kept outside, and it is only dx. And remember, limits are from 1 to 2. So what did we do? We separated into parts. 4x cube minus 5x square plus 6x and then plus 9. And very simple integrations, just do it. X cubed integration. What is x cube integration? X to the power 4 by 4. Minus 5. Integration of x square is x cube by 3. Integration of x is x square by 2. And for dx it is x. So it is 9x. Proceed. What do we need to do now? First substitute upper limit, subtract lower limit. So this is 4. X to the power, x is what? 2. 2 to the power 4. 2 2s are 4 2s are 8 2s are 16 by 4 is nothing but 4. Now substitute lower limit. Okay, what we do is we'll first substitute all upper limit, then we'll substitute lower limits. Minus 5. In place of x you write 2. 2 cube is 8. 8 by 3. Plus 6 into 2 square. 4 4 by 2 is 2. plus 9 into 2. So we have substituted all upper limits minus lower limits. So that minus can be kept outside the bracket and then do everything inside. So now substitute lower limit. So it is 4 into 1 by 4. 4 into 1 by 4 minus 5 into 5 into substitute 1, so it will become 1 by 3 plus 6 into, in place of x we write 1, so 1 by 2 plus 9 into, in place of x we will write 1. This whole thing will club and then subtract from that. So write down. You get 4 4s are 16. 5 8s are 40 by 3. 6 2s are 12. 9 2s are 18. And then while writing this, you open the bracket also, multiply all terms with minus. So 4 4 gets cancelled, so it is basically minus 1. This is minus 5 by 3. So this is basically minus 5 by 3, with minus it will become plus 5 by 3. Sorry. These are the first terms, so this is minus 1 as it is. And this will become minus, we have already written there. Minus is already there, so minus of minus it will become plus 5 by 3. Six, it will get cancelled 3 times, so minus 3 and minus 9. Club all the whole numbers first. 16 plus 12, 28. 28 plus 18, 46. 46 minus 1, 45. 45 minus 3, 42. 42 minus 9 is 33. Minus 40 by 3 plus 5 by 3 is minus 35 by 3. So this becomes 99 minus 35 by 3. 9 minus 5 is 4. 9 minus 3 is 6. So this is the answer. This is how we solve the problem. Some will be very simple, some will be little complicated. Yes, let us take up the next one. So, what is the function here? A trigonometric function. And what is it? Cos 2x. Okay. So, what is the procedure? What is the procedure we follow for solving problem? We will not worry about the limits. We will only take the function and do it as indefinite integral. Okay. So, what is the integral of cos 2x? It is sin 2x by 2. And what are the limits here? 0 to pi by 2. What is the sin 2x by 2? It is integral of cos 2x. If it is only cos x, it is sin x. But since it is 2x, 2 will come into denominator. Now substitute the limits. So this 1 by 2 can be kept outside. And then substitute upper limit first. So it will get sin 2 into pi by 2 minus sin 0. What is 2 and 2 cancel? What is sin 180 degrees? Sin 180 degrees is 0 minus 0. So the answer is 1 by 2, 0 minus 0 equal to 0. Okay. Next problem. Similarly, another trigonometric function. Do you recollect what is integral of tan x? Integral of tan x is log sin x. If you are not able to recollect, you can also find out. How do you find out? What do? We take tan x dx can be written as sin x by cos x dx. We take cos x as t, we get minus sin x dx equal to dt. So as a result, sin x dx can be written as minus dt by t. And what is integral of 1 by t? It is log t. Remember, it is minus log t. Substitute the value of t. Remember, you will get plus c also. So substitute the value of t. So it will become minus log cos x. Log cos x can be written as log 1 by sec x. So this can be written as minus log 1 plus log sec x plus c. Log 1 will become 0 and as a result this will be log sec x. So what is the integral of tan x? It is log sec x. I was telling sin x. That is for cot x. Okay. So this is the correct value. Log sec x. So 0 to pi by 2. Substitute the limit. This will become log sec pi by 2 minus log sec 0. Sec 90. What is cos 90? 0. Sec 90 is also 0. So this will become 0 minus sec 0 is 1. So it is minus log 1. What is the value of log 1? Is again 0. So you get 0 minus 0 equal to 0. So we are not learning anything new in this particular exercise. We are only trying to revise the problems of integration which we have done before. Okay. So let us move further to the next problem. This is our problem. Dx upon under root of 1 minus x square. The moment you look at the problem only, you should be able to recollect the integral. Can you recollect what is the integral of dx upon 1 minus x square? Can you recollect? Yes, the derivative of sin inverse x is 1 upon under root of 1 minus x square. So the integral of this is nothing but sin inverse x. Substitute sin inverse 1 minus sin inverse 0. What is sin inverse 1? We know that sin 90 is 1. So sin inverse 1 is nothing but pi by 2 minus this is 0. So the answer is pi by 2. I hope you are understanding. Very, very simple. We have already solved these problems. We'll just move to the next problem. Go to the next problem. We have dx upon x square minus 1. How do we do it? In the indefinite integrals, what did you do? If it is like this can be written as, we'll just take that part separately. 1 upon x square minus 1 can be written as 1 upon x minus 1 into x plus 1. Try to break into partial fractions. How do we do it? Let us say we write 1 upon x minus 1 and we also write 1 upon x plus 1 and x minus 1 in between minus. So you get x plus 1 here actually. You get x plus 1 minus x minus 1. So minus x plus 1. So you are getting 1 plus 1, 2 extra by separating like this. So what do? We write 1 by 2 outside, so that it automatically gets adjusted. So this particular function, the partial fractions are this. So write that. So this can be written as 2 to 3. 1 by 2 can be put outside, and it is 1 upon x minus 1 minus 1 upon x plus 1 dx. What is the integral of 1 upon x minus 1? Log x minus 1. What is the integral of this? Log x plus 1. So we get 1 by 2 log x minus 1 minus log x plus 1. Log m minus log n. What is log m minus log n? Or you can directly substitute also. There is no problem. You can even substitute the limits now. So this can be written as, first substitute upper limit, log, substitute 3. 3 minus 1 is 2, minus log 3 plus 1 is 4. So we substituted upper limit. Now substitute lower limit. When you are substituting lower limit, remember sign is minus. So minus of log, substitute 2. 2 minus 1 is 1. Minus of minus, that will become plus, and it will become log 3. How do you combine? Log 2 plus log 3. Log m plus log n is log mn. Okay. So 1 by 2. Log 2 plus log 3 will become log 6 minus log 1 into plus log 4 will become log 4, which can be written as 1 by 2 log 6 by 4. 6 by 4 can be written as 3 by 2. So the answer is 1 by 2 log 3 by 2. This is the answer for this particular problem. So basically it is more of recollection of integration, which you did as indefinite integral, but in a much easier way. We are not gone to the difficult problems. Okay. So let us proceed. Now slowly we are getting into interesting problems. What is the function? X dx upon x square plus 1. Don't worry about the limits. Absolutely don't worry about the limits. Just think about it is x dx upon x square plus 1. How did we do? We recollect that we generally take x square plus 1 as t. When you take x square plus 1 as t, what do you get? You get 2x dx equal to dt. What we have is only x dx. So in order to solve the problem, what we do is we write 1 by 2, 2 to 3, 2x dx upon x square plus 1. What is the advantage? The advantage is the moment you take this as t, this becomes dt. So dt by t, what is the integral? Dt by t is log t. So 1 by 2 log x square plus 1. And the limits are 2 to 3. So substitute the limits. So it is 1 by 2 log, substitute upper limit, 3 square, 9 plus 1, 10. So log 10 minus log 2 square, 4 plus 1, 5. Log 10 minus log 5. It will become log 10 by 5. What is 10 by 5? 2. So this is the answer. So this is how we solve the problems. So let us take up the next problem. Yes. As we are proceeding, we are getting little more interesting problems. How did you do? Forget about the limit 0 to 1. X e to the power x, how did you do? We know that we assume x square as t. If you take x square as t, what happens? You get 2x dx equal to dt. But you have only x. You don't have 2x. So what do we do? This can be written as 1 by 2 outside, 0 to 1, 2x into e to the power x square dx. This is our function. This is how we have to solve. So how do you solve? Very simple. Take x square as t. 2x dx will become dt. So what is left? It is e to the power t. What is integral of e to the power t? Is e to the power t. So e to the power t basically means e to the power x square, because that's what it is, x square. And what are the limits? 0 to 1. Substitute the limits. First substitute upper limit, e to the power, in place of x 1. So it is nothing but e to the power 1 minus e to the power 0. We know anything to the power 0 is 1. So it is nothing but 1 by 2 e minus 1. This is the answer. Hope you are understanding. Very simple functions we have already solved. Yes, this problem is something like the third problem. There are many functions. There were all algebraic functions, but here it is combination. So separate it. So this can be written as 0 to pi by 4. 2 can be kept outside. 6 square x dx, separate function, plus 0 to pi by 4 x cube dx, plus put 2 outside, 0 to pi by 4 dx. This is our problem. Try to recollect. Which function? Which is the function whose derivative is sec square x? Tan x. So integral of sec square x? Tan x. So it is tan x. What about this x cube? It will become x to the power 4 by 4. What about that? It will become 2x. And we will substitute the limits at once, 0 to pi by 4. Let this 2 be outside. So now substitute the limits. First substitute all upper limits. Tan pi by 4 plus pi by 4 to the power 4. Recollect, in place of x. So it will be like pi to the power 4 by 4 to the power 5 plus 2 into pi by 4. Now we have substituted upper limit. Now you have to substitute lower limit. So, and remember with minus sign. So minus tan 0 plus it will become minus, anyway 0. And this is also 0. And tan 0 is also 0. So basically these are the three numbers which are left, which can be written as tan pi by 4. Tan 45 degrees, 1. Plus this remains as it is. If you want, you can simplify 4 to the power 5 or leave it like that. These two will get cancelled and you will have pi by 2. This is the answer. Because all other things are 0. So very simple functions, as I mentioned time and again, is more like a revision of what you learnt. Okay? Yes. Look at this function. Don't worry about the limits. Forget about limit 0 to 2. Just imagine it is 6x plus 3 upon x square plus 4. What is common in numerator? What is common? 3 is common. Take it out. What will be left? 2x plus 1. If you take denominator as t, what you are going to get? If you are going to take denominator as t, what you will get? X square plus 4. If you take it as t, you are going to get 2x. And that 2x is there. So this problem can be written as 3 out, 0 to 2, 2x upon x square plus 4 plus 1 upon x square plus 4. What did we do? Here when we took out 3, that 3 will come for this also actually. Yes, the 3 will be outside, 2x plus 1. The 2x upon first denominator, the denominator, the plus 1 upon this. The advantage is for this, the moment you take this as t, that becomes dt, and the integral is log t. So it is 3 log x square plus 4. The limits are 0 to 2. Whereas, now look at this. When you see the function, you should be able to recollect. Can you recollect? Can you recollect the integral dx upon a square plus x square? What is the integral? What is the formula? It is 1 by a tan inverse x by a. Plus c will be there, but we will not take plus c because we are dealing with definite integral. So in place of a, what you have? 2 square. So the answer is 3 will be outside by 2 because a is coming out. Okay, tan inverse x by a. A is nothing but 2. And the limits are 0 to 2. First substitute upper limit and then substitute lower limit. So this becomes 3 log. When you substitute upper limit, 2 square is 4, 4 plus 4 is 8. So it is log 8 minus substitute lower limit, you will get log 4 plus 3 by 2. Substitute upper limit, 2 by 2 is 1, tan inverse 1 is pi by 4 minus tan inverse 0 is 0. Open. This is log 8 minus log 4 can be written as log 8 by 4. 8 by 4 is nothing but 2. So it is 3 log 2 plus multiply these two, 3 pi by 8. This is the answer. Log 8 minus log 4 will become log 8 by 4, which is log 2. So 3 log 2 plus 3 pi by 8. This is the answer. So the problems are that simple. Yes. This is the question. Same formula, what we applied just now. What was the formula we applied? Dx upon a square plus x square. What is it? 1 by a tan inverse x by a plus c. In place of a, you have 1. So our job is much easier. So what is it? It is tan inverse 1 by a is anyway 1, tan inverse 1, tan inverse x, 1 to root 3. Substitute. It is tan root 3, tan inverse root 3 minus tan inverse 1. You can either leave it here like this, or you can recollect inverse trigonometric function formula. What was it? The formula was tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus xy. You can use that. So what it will become? Tan inverse root 3 minus 1 upon 1 plus root 3. This is the answer. Either you can write like this or you can write like this. Both are correct. Okay? Yes. With this, we come to a close of this particular session where we had very, very simple definite integral problems. So basic difference between definite and indefinite integral is in the last step. What do you mean by last step? We integrate the function as it is indefinite integral only. In the last step, we substitute the limit. Apart from that, there is no difference. I am sure you are very comfortable doing these problems. As far as assignment is concerned, whether it is yesterday's assignment or today's assignment, you would have observed that I am actually doing all alternate problems. Yesterday, in the exercise, we had 6 problems. We did first, third, fifth. So the remaining problems are there for you to do as assignment. Similarly, if you observe today, we have done problems from 1 to 21, but I was only doing odd numbers 1, 3, 5, 7, 9, 11, 13, etc. Remaining problems, you please attempt and learn. Okay? In the next session, we are going to take up little difficult functions. Because as you learnt integration also, initially the functions were very simple. As we progressed, the functions became more complicated. Same way we are proceeding in definite integral also. So you will find this particular exercise very, very simple. So please do it. Don't postpone it. All the remaining problems you do it in your notebook, and so that you are ready for tomorrow's very, very interesting class where we have some difficult functions to integrate. Thank you. Sai Ram.